Setley.
And much other.
Rather than sit down and cry and think about how I'm not getting done school.
Indeed.
Yeah.
I waste time in different ways.
Why is English 4 required, but there's no math class or science class that's required for your 4th year, or senior year?
Because they don't think you need math, which is why the world ends.
Common Core.
And everybody thinks that vaccines give cancer.
Doctors.
No, just autism. Everyone knows that, Michelle. Jesus Christ. What are you talking
It's gonna
about?
Are
be
you
from,
recording?
like,
I am recording.
Awesome.
for like the past 5 minutes.
I love hearing, like, going on the recording and being like, oh, that's so-and-so, that's so-and-so.
Oh, it's really
We
hard
talked
to
about that day.
distinguish too. All, let's see, 1, 2, 3,
Yeah.
4, 5, 6, 7 of us now. Wow.
Ooh. Ooh, ooh, ooh.
It's the story.
The brains is happening, so
All
How I
practice.
died.
all the brains have are you playing all practice. Like a
Trebuchet hacks.
execute minus 2.
Okay.
Oh, I knew it was 1.
Okay, what do we do?
Alright,
You substitute.
antiderivative.
No, first, x to the 3rd minus 2 equals u.
Okay, we gotta make a u substitution.
U substitution.
The only one you change.
Okay, so we
We
go
get a new
u
class.
equals x cubed minus 2, so
Where did that come from? Let's see.
du is 3
D
X to the
equals,
x
uh,
squared.
Mine, nope,
That's all.
not,
that's the derivative.
plus c.
No,
Crap.
that's it.
That's it, what are you?
It's
Oh,
not-
dx, oh, ka-chow.
okay, so what do we got?
Yeah, I'm still like.
We've got a u, and then that's what's left over, right?
Hey, you
Yes.
took times by 3.
Okay, so now what?
Now you take and you put
You substitute.
some,
So yeah, so divide by
so
x squared minus dx.
Okay, so we've got a what's this gonna look like then?
3u, and square root of
U to the 1/3.
Okay, so u to the 1/2
That 1/2, yeah.
times, what's this?
du. No.
3 over du.
Du over 3.
Okay, so a 1/3 du.
So
Right.
du.
Okay, so what's the answer to that integral?
1/3.
So that's just,
U-
3/2
U
over
to
2
3
to
halves
3.
over 2.
Okay, so that's a 1/2
Oh, wait.
u to the 3/2, correct?
Mm,
Yeah.
mm-mm. Wait,
No,
No, the negative 1/2.
to the 3/2, 2/3, so it's I need 2/9 there, don't I, up front?
I don't know.
Right, because I've got to do a u to the 3/2 times 2/3 times 1/3 is 2/9.
2.
Right.
Okay.
Okay. And then plus c, what's the last thing to do?
Substitute in.
Okay, reverse the substitution. Good, and so we end up with 2/9 times the quantity
X cubed.
x cubed minus 2 to the 3/2 plus c, right?
Yes.
All right, heck of a deal. Okay, last thing I'm going to show you then. You guys are in great shape then. You've got, we're moving on. This is good. This is real good. Okay, so what about something like this? Okay, what if we've got, what if we've got the integral of x times the quantity x squared plus 1 cubed dx from 0 to 1.
We'll just do the same process with that at the end.
Okay, same process, right? Now, what's going to happen at the end of this? So we're going to have the same process,
Then we're gonna plug in numbers.
and then we'll plug in numbers. Go back to x's. Okay, that would work, but I got a better answer for you. So let's do the same process, but this is a different kind of integral, right? The last one was an indefinite integral, and so the answer is a family of curves, right? What's the answer gonna look like here?
Specific number.
Yeah, it's a number, right? This is an area function, right? So we're looking for the area under the curve. Okay, so let's make our U substitution, and what do we get?
X squared plus 1.
Okay? And so, what's du?
2x dx.
So what do we got then?
Just,
1 half on the other side. Let's see.
x cubed du, or y cubed du. Yeah, du. Yeah.
You said y cubed.
You said-
Oh, okay, well, whatever.
Y cubed.
Okay.
Yeah.
That
was.
Okay, so here's what we can do though, right? Being as we're just looking for an area under the curve, why not also convert the limits of integration? Right? Let's make a change. We made a change in variables. So how do we get from here to here? Well, when
Multiply by 1 half.
x equals 0 gives us what value for u?
1.
Yeah, everybody agree? Okay. What about up here? X equals 1
2.
gives us a value of u equals 2, right? So let's just not, there's no need for us to go back to x's this time, right? So what's the answer to this?
It's just that's half of the.
4 minus,
Well, what's the antiderivative?
oh,
U to the 4th of 4.
Okay, so we get a 1/8 times
U to the 4th.
u to the 4th evaluated from 1 to 2, which is equal to 1/8 times what?
or no, 2 to the 4th, 16 minus 1.
Okay, so we get 15/8. Okay, let's look at this. So if we were to, for example, okay, so let's do something here. So let's, first of all, let's look at what the area looks like under the original curve from 0 to 1. I want you to see something. This is really cool. So we've got the quantity x times the quantity x squared plus 1. Everybody look at this. Stop what you're doing. Cubed, right? And let's graph that on the interval from 0 to, I'm going to go 0 to 2. Okay, and we'll go zoom fit. Okay. 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 Now let's go look at this other one. Right, so this other function is just u cubed, right? Okay, so now we'll go down here and we'll graph x cubed, 1/2 x cubed. Okay, and let's graph that. Okay, so we can expand this thing quite a bit. So let's evaluate the first function at 1, and we get 8, right? So let's go in here and let's set the window. So y max is something like 9, how about? Okay, that's a little better, right? Now let's add up some areas under the curve. So let's go back and let's find what the area under the first curve is from 0 to 1. I want you to see something interesting here. So if we go second calc 7, lower limit 0, upper limit 1. Oh, what do you know? That's pretty familiar, isn't it? Right? That's 1 7/8. Right? Now let's do, while we're at it, let's go so let's scoot down to the other function, and the lower limit becomes 1 and the upper limit becomes 2. And what do you know? So it resizes the graph. It does something interesting. It actually gives us a new space. Instead of being in f of x space, let's call it, right? It puts it into the space of a different function. And so it resizes the curve, but the area under the curve remains the same. Effectively, what we've done is we've taken this area and we've just reconfigured it. Right? Pretty cool. Right? So there's no need for us to go back to the blue space when we can just find the area in the red space. Now that's not going to work for us for an indefinite integral because the shape of the curve is different. And that's really what we're looking for, is the family of curves that match that shape. Right? But that's a different envelope than the red one is. But for a definite integral, who cares? All we want is a number. Right? Does that make sense? Okay. All right. Thus ends today's lesson. You may work.